Hello students, in this class we will discuss how to delete a node from BST. In our previous class, the same was discussed how to delete a node from BST manually. But today's class is about writing a program or developing a function for deleting a node from BST. So today's purpose is to write a program or develop a program, and for that you must understand how to delete manually. If you have not gone through my previous lecture number 6 on trees, then you are advised to first go through lecture number 6 and then come to this lecture. So as we earlier discussed, that deletion is performed in three cases: case 1, case 2 and case 3. Case 1, when the node to be deleted has no child. Case 2, when the node to be deleted has only one child. And case 3, when node to be deleted has both the child present. So here I am taking this nomenclature. P is pointer of key. What is a key? So I have mentioned here, the value to be deleted is called a key. So we will delete according to the key value. So we will ask the user to enter the key value to be deleted. So user will give you some value. So that is what we are calling key. Pointer of key is P. So we will refer in our coding, P is a pointer to the key, and FP is pointer to the father of key. So say if I want to delete 55, then P will be pointer to 55 and FP will be pointer to 60, because 60 is father of this 55, which is a key, for example. So first of all, we need to ask the key value from user, what user want to delete, and then we need to set this pointer P and FP. So how to find P and FP? So that we will learn here, and these are two pointers which are local to BST del function which we are developing. So we will, this is name of our function which we are developing, and this is a name given by us. So this is nothing like a standard name. You can give BST delete, BST del BST, whatever name you want to like to give, but here I am taking BST del. So we are learning how to reach P, how to find P and FP. So start from the root and move your P from left to right, left or right, again and again, depending upon the value of key. So this we have done many a times. If we want to move a pointer P to 55, say for example, then I will start from root, and then according to this key value 55 and this value 50, I will decide to move left or right. So I have moved here on left side, this right side 80, and then 80 is greater than 55, so I'll go on 60, and then 60 is greater than 55, so I will go on left. So in this way we keep moving left right again and again, depending upon the value of key and node value. So here read a key, that is scanner %d ampersand key, that key you have taken from user, then FP equals to null and P equals to root. So you are putting P here and FP is null initially, because there is no father of root. Now you will move this P and FP will follow it. So that this work we have done many a times, you will understand it, that what we are doing, FP equals to P. So this do while loop is there. So FP equals to P. That means that we are copying P into FP, and then P will be moved on left side or right side, and that how that it is decided left or right depending upon the key value and P info. So if key is less than P info, P equals to P updated to be P left, and if this key is greater than P info, then P is updated to right, else we break. That means if value are equal, then break is done. and this work is done while P not equals to null. So until unless P becomes null, say if key value is less than this, then it will go left, otherwise it will go right, and if both the values are equal, then it will be a break. But say that value is not existing in the BST, the key value is not there, then we also need to break the loop somewhere. So what we will do, we will keep this condition while P not equals to null. That means if P becomes null, the loop will be broken automatically, and P will become null only if that value is not found, because if value is found, this else break will work. So in this way you are moving P and FP. FP is father of P. See, I'm again reminding you that after understanding this all things, you should write this statement: FP equals to P below this else, below this else. You will ask, why sir, why to write below this? So I have mistakenly put it here, but as I explained you this topic, I noted that if P and FP are equal, this break will perform. If if the value of key is equals to P info, then this break will perform. At that time, P and FP will remain equal, and if they are equal, then what will happen? That father and P pointer will be equal. So we don't want that. We want that P should point to the node to be deleted and FP should point its father. So this copying process is done later on. So if both are equal, break will be performed and there will be no copy. P and FP will not be copied, and FP will be father of P. I hope you are getting this point. So in this way, you can move P and FP. The only change in this code you need to do is put this line FP equals to P below this else here. Otherwise, this will be working perfectly. And if you don't put this below the here, then both P and FP will be equal when this break will act. And that we don't want. We actually want that P should point to the node to be deleted and FP should point to the father of P. So by doing this, you will have your pointer P and FP. If P is null, that means key does not exist. P will become null only if the key is not there. If key is there, then this else will work. So now you have taken your pointers P and FP properly, and now you need to decide case 1, 2 or 3. So case 1, 2 or 3 means how many child the node to be deleted have, and according to that you can create your own 3 functions: bst del 1, bst del 2 and bst del 3. You can call those functions according to the cases. So what I'm doing here, if P is not null, what if P is null? P is null, then means key is not available in the BST. So in else portion I'm writing here key does not exist. You can see here below else portion I'm writing key does not exist. So if P is not null, that means key exists and P is pointer to it, FP is pointer of its father. Then see how I decide case 1, 2 and 3. If P left equals to null and P right is also null, then this is case 1. So I'm calling BST del 1 and I'm passing P and FP, means node to be deleted and its father. Pointer to node to be deleted and its father are passed to del 1 function. Else if P left is null or P right is null, means both are not null, but any of them, one is null. In that case, I'm calling BST del 2 and also passing this P and FP. P and FP means P node to be deleted pointer the pointer of the node to be deleted, and FP is pointed to its father. Or else means both the child are present, and I'm calling case 3 BST del 3 P and FP. So in this way, we can organize our function BST del. What it is doing? This function is only marking the pointer P and FP by this loop, and after marking P and FP, it is deciding which case is applicable, case 1, 2 or 3, and according to that it is calling different functions. So our BST del function is like this. Now you need to write these three functions, BST del 1, BST del 2 and BST del 3. So you have pointers, not to be deleted pointer P and its father FP already marked. So now you come case 1. So here two pointers you are receiving P and FP. So you are writing void BST del 1 struct node pointer P struct node pointer FP. So P and FP are the pointers. P is pointer to the node to be deleted and FP is its father. So how to delete that? So we discussed in a previous class that if there is no child of the node to be deleted, then you just remove it. And if you are removing it, then in its father's hand, which is freed, so you will write null there. So in which hand of father you want to write null? So if FP left is P, because P is being deleted, we are deleting P, we will set it free afterwards. But before that we need to decide FP left is P, then FP left is null. Otherwise FP right is null and then free P. So these 4 lines code will delete a node which have no child. So I hope you are getting this point. Now you will write this code for the BST del 2, case 2. Case 2 means one child is present. Which child is present? That we need to decide. And we will delete that node P and its child will be handed over to its father, FP. So we need to decide a few things like this. Say, if P left equals to null, it means P right is present. Child of P, right child of P is present. So we need to hand over right child of P to father. But in what hand of father? So left hand of father, because P is deleted and the right is deleted. So P, if this FP left equals to P, if P is child of its father in left hand, then father's FP left is P left. Otherwise, FP right is P left. Means here you have decided that P left is equals to null, not null. P left is not null. Here P left is not null. I have not taken null. So P left is not null means left child is present. So that left child you are handing over. So here P left, P left. So this P left is handed over to the father. But which hand of father? So that you have decided here, like FP left equals to P, then left hand of father, else right hand of father. So you can write this code by taking double equal here also. According to that, your code will little bit change. I'm taking it not equals to null. So I have decided here that left child of node to be deleted is present, right child is absent. So that left child is required to be handed over to father depending upon which hand of father is freed. So if FP left equals to P, then left hand of father is freed after P is deleted. So we will give this P left to FP left. Otherwise we'll give this P left to FP right. Else means the right child is present. So we are deleting P. So P right will be handed over. So you can see in both the cases, else and if, P right is handed over. Handed over to whom? Handed over to the father. And which hand of father? So if P left, FP left equals to P, means if node to be deleted P is left child of its father, then left child is freed. So we will hand over to the left child or father this grandchild. Otherwise, we will hand over right child of right in the right hand of father. FP right is equals to P right and free P. So after doing this, after setting the pointers at appropriate place, the child is handed over to the grandfather. The father is now freed. That means it is deleted now. So in this way, you can accommodate or do this BST del 2 case. Now I'm coming to developing a code for BST del 3. That means case 3. Both the children are present. So I hope you remember that when manually we do this, what we do, we go to the rightmost in the left subtree of node to be deleted, or we can go on the leftmost in the right subtree. So there are two options, but we need to work on only one option. So what we are doing here, we are taking this, say I have taken here this p is the node to be deleted, fp is the father of it. Then I'm taking a temporary pointer. There is a pointer x which is p left. P left means I'm moving to the left subtree of the node to be deleted. So this x is a starting of left subtree, and we will go to the rightmost position of it, and then struct node y is equals to p. So y is equals to p means this is a copy of y, a copy of p, node to be deleted. So y is a copy. So what we are doing, I'm moving right side. So father is also marked this father, because if p left is x equals to p left, it means the x is child of p, and this p is father. So this y father is copied in y. Now I'm moving right side. So x right is not equals to null. So until unless x right not becomes null, I will keep moving right, 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 right. So x is equals to x right, x equals to x right, x equals to x right, again and again. But before jumping x, I will copy it into y. So x is the uh, rightmost, like ultimately y is its father, and x will become the rightmost of left subtree. So x right not equals to null. So x will become the rightmost, because x right will become null, it will stop. So x is the rightmost of a left subtree, and y is its father. So y is father of the rightmost in left subtree. Now you swap. So what to swap? The swap the value in node to be deleted p. So p is there, and you need to swap it with the rightmost, that is x in left subtrees. So temporary is equals to p info, info equals to x info equals to temp. So this is the standard swapping code. Something temporary is equals to taking, you are taking p info, then p info is filled with x info, and x info is filled with temporary. So both the values are swapped. And now the issue becomes that which node ultimately we need to delete now. So see, uh, we need to send call bst del 1 or del 2, case 1 or case 2, because the node which we have swapped, he has either one child or zero child, because right child is not there for x. So x left equals to null, and x right equals to also null. This right you need not check, because it is null only, x right is not there. But if x net, if you check both, then there is no problem. So both the child are absent, then you are calling case 1, and otherwise you are calling case 2. So what you are sending to case 1 and case 2, you are passing x and y, because x is the now node to be deleted, and y is its father. So by doing or writing these four functions, these are four functions, I have created this in modules. If you want to write only a single function, you can also club all the functions, all the things, by writing few if and else. But this is a modular approach. We have developed the modules, and we have called them. So if you have gone through the lecture 6 also, after that you have practiced a lot how to delete a node when it have 0 child, 1 child, or 2 child. After that you should think about developing a program. By my releasing this video, many of you have already done this work, because this was discussed in the Google Classroom also. But some of the students were requesting to also upload a video, so I am uploading this video. I hope that you will do it by yourself, by understanding the things. My purpose of explanation is only to make you understand how you will proceed. There can be small mistakes like semicolon, colon, and some not equal condition. So when you will develop the program, you will run it. You can resolve it by yourself by practicing it. And I hope you will not copy it as it is, and then will not act as a typist. You will act as a programmer. So you will develop your mind as a programmer. So thank you very much. Before I conclude, I have these concluding remarks here also. So I am reading it out. In this discussion, we have discussed deletion operation in BST. To develop a C program, we will use 4 functions that will perform deletion of given key. Void BST del is the main function. Then it will call del1, BST del2, BST del3, and how this function code can be written. You can you might have understood by this video lecture, and you should also, I have again telling you that see the lecture 6 before doing this, and practice before manually before writing a code. Thank you very much.